All right. Welcome to the May Mimir Community Call. I'm Vernon Miller, software engineer on Mimir. So just going through the agenda today, we have some updates of stuff we're working on. The first item on the agenda is about reducing query or memory utilization. Marco, do you want to talk about that?
Yeah, sure. So I'm actually speaking in charge of Ganesh and Charles. They are both engineers from Grafana Labs. They are not in this call today. So over the past month, they worked to introduce an experimental feature in Mir, which is expected to significantly reduce the memory utilization peaks in the Mimir query. The main idea of this work is that instead of having to loading upfront all the chunks, which are basically batches of compressed samples, before executing the PromQL engine, these chunks are actually read from the ingesters in a streaming way while the PromQL engine is running. So the idea is that we will start running the PromQL engine while downloading the chunks from the ingesters, and we will keep downloading the chunks from the ingesters while running the PromQL engine at the same time. So far, we did some testing in a dev Mimir cluster, and we got some promising results in terms of memory utilization reduction in the querier. However, we just tested a very small set of queries, like the most common one. Sum rate is the first query from which we started, which is also the most common one in Prometheus. So more testing is required, and we also want to run. We also want to start testing this new feature, in a bigger Mimir cluster. But so far, the results we got are pretty interesting. There's one main downside, which it's something we are still working on. When you enable this experimental feature, it's expected to increase the ingester CPU utilization. Now, the real question is by how much, and that's what we want to measure in our production clusters. The reason is that when you enable this feature, we have to sort the series by labels inside the ingesters instead of doing it inside the queries. And this sorting actually hits a significant amount of CPU, which may be visible in terms of CPU utilization of the ingesters. That's definitely something we will keep an eye on. We are also very sensible to try to keep the ingester CPU as lowest as possible. And maybe there is also room for some optimizations there. I think we will have some data to share, not for the next release, which is the 2.9 expected. The release process is expected to start next week, but probably in the release after. So in Mimir 2.10, we should have some data to share with the rest of the community.
All right, thanks, Marco. The next one I can talk about. So a feature that we've started working on is per series extended retention, and we're still finishing up the design phase and working on a proof of concept. But the idea is, you may have a ton of metrics. Let me admit. Okay, you may have a ton of metrics, but some metrics are more valuable than others, and for some subset of those metrics, you may want to save them for longer than the default retention or the retention that you would like for your less important metrics. So the feature we're working on is to, on a per tenant basis, to define 2 tiers, a default tier, and then an extended retention tier. And the user would select a set of series that they want to be retained for longer, and then Mimir would automatically move those those series to the extended tier once they kind of age out of the default tier. So the benefit is that right now you may a customer in the situation is faced with either having separate tenants and it's an operational headache, or to set the retention to the maximum required, which then increases storage costs. So this is something we're excited about, and should have more updates in future community calls. All right. Next one is about reducing memory utilization in store gateways. Dimitar, do you want to cover that?
Yeah. So last few months I've been working on reducing memory utilization in store gateways. The gist of it is that the store gateways now can trade fetching postings from the TSDB index for fetching series. So overall, the volume of data from the TSDB index should be reduced. We've seen this to greatly reduce peak memory utilizations in the store gateway. Like in some cases, memory becomes pretty much flat, whereas before there would be peaks up to like 50, 40 gigs of Go heap. This is still, so this works most of the cases. Whenever the usage pattern is such that it doesn't benefit from this optimization, the store gateway ends up fetching slightly more series than it needs to, and this ends up increasing CPU, by roughly 2x in some peaks. We're experimenting with different ways to account for this. And if we manage to get a reasonable trade-off, I think we just flip the default in 2.9.
All right. I actually had a question about that, Dimitar. I saw the parameter you have there to try out setting the worst case. I think there's, if I'm correct, there's like 3 different choices for that parameter. Is that right?
There are, yeah. So like worst case sounds bad, but like worst case refers to optimizing for the worst case in fetching data. So it assumes you'd fetch many series and then it tries to fetch postings which are in volume no more than that. So you can have worst case. You can also have speculative, which assumes that with each selector in your query, the number of series the query would select halves. And then in this way, it decides how many series and how many postings to fetch. There's also worst case small posting lists, which favors postings a bit more than series. So this is a version of worst case, but it should have it should be less aggressive and less optimistic. And there's all, which is just the default, which kind of disables the optimization. I'll add these to the doc.
All right. Yeah. Thanks, Dimitar. And on the next item, I've actually been looking at some of Marco's PRs around the compactor reducing object storage API calls. It seems like it could be pretty huge. Marco, do you want to talk about that?
Yeah, sure. Yeah, I wouldn't call huge, but I'm working. Actually, I worked on a couple of optimizations to reduce API calls issued by both the compactor and the ruler to the object storage. So ruler, the ruler synchronize the configured rule groups on a regular interval, which is configured by the configuration option called ruler poll interval, and by default is 1 minute. However, most of the time, there are no changes to the rule groups between two consecutive intervals. But unfortunately, the ruler doesn't know unless keeps checking all the configured rule groups to the storage. What we did was introducing another way to sync the rule groups, which is a sort of event-based. So whenever you call the ruler config API to change the configured rule groups, a notification is pushed across the ruler replicas, and a resync is triggered. This is in addition of the periodic polling, but we expect that thanks to this feature, we will be able to increase the polling interval, because we expect that most of the unless edge cases or race conditions, we expect that the syncing will be actually triggered always by the events. We are rolling out this feature to production right now at Grafana Labs. So based on the results there, I expect to eventually change the default poll interval in Mimir to increase it. There's also a configuration option to disable the new event-based sync. The compactor. So the compactor issue a bunch of object exist API calls to the object storage. Like at Grafana Labs, if you look at all the object storage API calls issued by the compactor, 96% are these objects exist on the block meta.json file. So after some work and some refactoring in the code, we changed a bit how we discover the blocks in the storage. And we have been able to reduce, completely remove this object exist API call. This feature, I just worked this week on this. I merged the last PR a few hours ago. So we will start rolling out this feature to our dev clusters next week, to our prod clusters the week after. So I should have some results to share in a couple of weeks from now.
All right, thanks, Marco. And the last item around, Matt, you have a question. Go ahead.
I was only curious if you had a second to mention how do you know, presumably we needed to know that the object exists or not. And so what is the detection mechanism for that if we don't do the, I don't know, where they had calls maybe before?
Yeah. So before the changes, the compactor was doing two different things. One, we were listing the blocks, issuing a list object API call. And when we list, what you list in the object storage are sort of prefixes. So when we were listing, let's say, blocks, which are basically like directories in the object storage, you can get 1,000 of blocks in each list object API call. So the number of API calls you have to issue to list all the blocks of a tenant is not equal to the number of blocks for that tenant inside the object storage, because we list 1,000 with just one call. But then for each of them, we were checking if the meta.json file was existing. And the reason why we did it was to check if the block if there was a deletion in progress on the block. Which means when we delete the block, we started deleting the meta.json file. It's our way to trigger that the block should be ignored when the meta.json file does not exist. And then we delete all other files of that block until all the block is deleted. Now, there could be a deletion in progress for that specific block between when we issue the list object call and when the compactor run the planning and start the compaction. So yeah, we were basically checking every meta.json file of each block to see if the block was, if there was a in progress deletion or not. And that was inherited. I mean, this code was years old. It was originally inherited from Thanos, in a different state of the world. Now we have the bucket index in Mimir, which is mandatory. So we can infer the same information from the bucket index as well. So before listing objects, we actually look up the bucket index, which is just one call per tenant, to check all the blocks which have been marked for deletion. And then we use this information to check whether a block should be excluded or not from the compactor, because the compactor doesn't need to take into account any block marked for deletion. Sorry. So we can just exclude all these blocks without checking the meta.json file. Sorry, it was a long description, but unfortunately, it's quite tricky the way it works.
Yeah. No, I asked and I appreciated that. Thanks for the in-depth rationale.
Yeah, very informative. All right, the last item is that next week we'll cut the next release from Mimir 2.9, and so after that it will run in our dev and production environments and then be published. So that's the end of the regular agenda. So now it's kind of open. Anybody has questions, share pain points, anything.
I would have a question. I'm in between meetings, so I'm trying to see how much time I have. I see that there is a new recommendation now in the documentation for the compactor to basically have one shard every 8 million active series instead of the old 25, 30. Is that recommended for all use cases, for big tenants as well? Why there was a change? Is there any pros and cons to changing them? Is it faster, or because what was the limitation there? Or
I'm not very familiar with. I saw that change, but I'm not familiar with the rationale. Anybody else on the call now?
Yeah, just for some concept. So it's going to be a big change for us because right now we have 64 shards and the per tenant. And so if we go from 30 to right now I think we are considering the 30. So we would need to multiply by quite a lot. So we would have 250 basically shards.
Yeah.
Is there any problem with that many shards, or?
Yeah, my quick answer here is: do you have any problem? If not, don't change the configuration. So there was some discussion internally whether we should recommend we should keep recommending one shard. I think we were recommending in the documentation one shard every 20 or 25 million. And then, some people from Grafana Labs suggested that we actually, at Grafana Labs, we actually run with a lower target than what our documentation say. Yes, we run with targeting nearly 8 million, 10 million. So yeah, there was, this question raised. Someone proposed to change it. We had some brief discussion internally. I personally didn't have a strong opinion. The takeaway is if you increase the number of shards, you may better parallelize the querying, both the compaction and the querying, up to a certain degree. Which means, if you target, I don't know, 1 million series per shard, you end up probably with too many shards, too much overhead, and querying all these small blocks. But targeting between 10 and 20, 25 million active series, I think it's a reasonable number, at least based on the recommendation we also give in terms of CPU and memory requirements for the store gateway.
So I shouldn't so it's fine if we stick with like the 20, the 30.
Yeah, if it works fine for you, yeah, definitely.
Well, for now it works fine. It's difficult for us to know if it would work better, because it would be like a very difficult experiment to run, because we have 900 million active series, and replicating this data and then having the heavy query that we are having in production would be kind of a tricky. So
yeah,
I wouldn't know really how to know if changing the shard, even because when I change the shard, then I can't really go back. Well, I can go back in a future time, but all the blocks that are compacted remain compacted the same.
Yes, correct.
Yeah. I have a meeting now. Okay, thanks. Well, that's good to know. So we don't need to maybe to change this dramatically. Maybe I will try to. We are trying to get the number of shards like as a power of 2 basically, and the shards as well that the query use, so at least they can kind of interact with each other, even if in the future we change the number of shards or for the compactor.
Yeah, that's definitely recommended if you don't do it already.
Okay. Then maybe I will, if we change that, I will try to see how are the queries, if they see they're faster or not. Maybe I can, I don't know, let you know if that information is useful. Okay. Thank you very much, guys.
All right, thank you.
Can I have a follow-up question on per series retention?
Yeah.
How are you doing this? Like, are you cutting new blocks? Are you making use of the tombstones from EPSS? Still not decided.
So Tyler, correct me if I'm getting anything in the design wrong, but yeah, we'll use like a series matcher to specify what series to include, and then when the compactor would normally mark blocks for deletion based on the default tier retention, they would recognize based on extra information that we put in metadata.json or in another file just in the same directory, which series need to be kind of extricated from that block and then written to a new block in the other tier.
So this happens when you cut a block?
No, when normally we would delete a block at the end of the default retention.
And then you look up whatever the current setting is and then retain all of those. Okay.
And so and that makes it kind of a no-op if if a user decides, oh, actually, I want to keep these in the default tier, if they haven't aged out and put in the other tier, just, you know, just a no up.
That's neat. Super cool.
All right. I guess we have no more outside joiners, but any other internal discussion? Okay. I guess we'll end it here and see everybody next month.
Bye-bye.
Thank you. Bye-bye.
Okay.